Okay, so let's look at damped oscillation. So welcome to lesson 7139. So here's our vocabulary. Take the time to read it. This is more for physics classes than anything. So this will have implication in a physics class. All right, identifying damped oscillation. So for each of the following functions, determine if the graph shows damped oscillation. If it does, identify the damping factor and tell where the damping occurs. So we're going to do this problem. Okay, so from the definition, basically the way this works is that A is damped oscillation because 2 to the negative x, a function times a trig function, becomes our damping factor. So yes, this is a damped oscillation, and our damping factor is the function 2 to the minus x. And we can see that when we graph it, you can go ahead and graph it. Change your windows to negative pi to 2 pi. You don't have to worry about the x scale, the y scale. Take it up. Probably 5, 10, 15, so you can see the top of the graph. Okay, so let's look at B. 3 cosine 2x. This 3 is an amplitude change. The 2 is a period change, or change the amount of waves per period. So this is not damped oscillation. There is no function multiplied. It's just a constant, which is an amplitude change. Okay, let's look at C. Negative 2x times the cosine of 2x. This is damped oscillation, and our oscillation factor is negative 2x. So yes here, and yes here, and no there. And you can graph these and prove it just by looking at the graphs. Okay, so in oscillating springs, if you have a spring attached to a weight and you pull the spring back, it's going to go back and forth, but friction is going to cause the spring to slow down and stop, even if the weight is on an air glider. So this is something physicists like to do. So here's our function. You can never see white on here. Here's our function. This is our damping factor. So this spring does damp. So now what we want to know is how long does it take for the spring to be damped so that the oscillation is between -1 and 1. Okay, so basically you can graph this, and between 11 and 12 seconds. So when you put that function in there and you go to your table of values by hitting values. So first you're going to hit y equals, type this into the calculator, then hit second graph, scroll down. When you get to 11, it should be a little bit above, outside of the range of 0.1 and 0.1. Okay, now what you're going to see as you go down the table of values is at 9 seconds, we're at negative 0.113. Then at 10 seconds, it goes back up to positive 0.0487. You would think it would happen between 9 and 10 seconds, but it looks like it keeps going up beyond 11 seconds, then it comes back down again. So you can use the trace to see where in between 11 and 12 seconds or 10 and 11 seconds if you hit your peak, because we're not sure at the numbers in between 10 and 11 seconds where the peak occurs. So we want to see if we can get the peak, and that will answer that question. So That's what you do for B. And the damping factor is the function that multiplies to the trig. Function 0.065 negative. And we put the x in the calculator, not t. But the xt theta n includes t for time. Now go do some practice problems.